Functions group related statements together and reuse them whenever needed. Instead of writing the same code multiple times, you define it once and call it whenever required. Python uses a keyword def to define a function, short for define. Defining a function doesn't execute it immediately. You must call the function using its name followed by the parenthesis. When called, control jumps to the function, executes its body, and returns to the caller. The functions can take parameters that are special variables that receive data from the caller. Each time you call the function, you can pass different values to it. So these input values are known as arguments. Function can return results using the return keyword. When Python hits return, it sends the result back to the caller and exits the function. The returned value can be stored in a variable, used in expression, or passed to some other functions. Functions receive data with the help of parameters and arguments. Python gives a flexible and powerful way to pass arguments, so positional, keyword, variable length positional arguments, and variable length keyword arguments. We will go step by step, show how Python matches the call arguments to parameters. We will learn how to pack and unpack the arguments and the rules for mixing styles safely. First, a quick catalog. Arguments can be passed by position or by name. You can supply defaults, use static args or static kwargs to accept an arbitrary number. Here, greet hello Alice passes hello as a first positional and Alice as a second. Python assigns them to parameters by order. So hello goes to greeting and Alice goes to name. Positional arguments are the simplest, so Python assigns values to parameters in order. A swap in order changes behavior or produces errors if you have fewer arguments than parameters. Keyword arguments let you pass values by name instead of position. Keyword arguments are matched by the parameter name, and this improves readability, and this is useful when functions have many parameters. You can also mix positional and keyword arguments. For example, positional must come first in the call. Next is arbitrary arguments. If you do not know how many arguments will be passed into your function, add a static before a parameter name in the function definition. This way, the function will receive a tuple of arguments and can access the items accordingly. So the static args syntax packs any number of extra positional arguments into a tuple. This is great for functions that accept a variable number of inputs like print or aggregate functions. Inside a function, you treat args like a tuple. So static args collects extra positional arguments into a tuple. You can use any name, by convention static args, useful when caller may send variable number of items. Double static kwargs gathers any extra named arguments into a dictionary. This is widely used for flexible APIs and forwarding options to other functions. So kwargs and with double static packs extra keyword arguments into a dictionary. This is used when function accepts flexible named configuration. When the static or double static operator is used in the function call, the static operator unpacks the data structure such as a list or a tuple into arguments needed by the function definition, and double static operator unpacks a dictionary into the arguments needed by the function definition. So at call time, static iterable expands into positional arguments. Double static mapping expands into keywords. So this is useful to forward arguments or call with dynamic data. So the X and double static operators at the call site do the reverse of that static args and static kwargs. They unpack sequences and mappings into arguments, which is very handy to forward list or dictionaries into functions.